They told us the golden rule of AI was simple. More data is always better. But what if that's actually wrong? What if piling on more data doesn't make AI smarter? It makes it worse? Today, we're pulling back the curtain on a secret that data scientists don't always admit. Choosing the right data matters far more than collecting mountains of it. And once you see this, you'll never look at Netflix recommendations, Amazon suggestions, or even social media feeds the same way again. We'll break it down with something everyone understands: soup. And trust me, once you see how junk ingredients ruin the recipe, you'll finally get why bad data wrecks even the smartest AI models. So don't skip this. If you really want to understand how AI works in the real world, this episode is a must. Hit play, listen all the way through, and by the end you'll know the secret ingredient that makes AI truly work. Let's dive in.
We're always told that for AI, more data is better. Always. But what if I told you that's not the whole story? Today, we're pulling back the curtain on a secret that's absolutely fundamental to making AI smart. And it's all about choosing the right data, not just piling on more of it.
Right? For years, the mantra has been big data, big data, big data. But what if that's actually wrong? What if just throwing more and more data at a problem can make your AI worse? It sounds completely backwards, I know. But trust me, understanding this one concept can be the difference between an AI that works miracles and one that's a total dud.
So to get our heads around this, let's just forget about all the complicated code and algorithms for a second. Let's talk about something we can all understand: soup. Yeah, soup. Because building a great AI model is a lot like cooking the perfect soup. It's not just about how good of a cook you are, it's about the ingredients you decide to put in that pot.
Okay, so stick with me here. You're the chef, but your pantry, it's not some cozy little kitchen pantry. It's a massive warehouse just packed with millions and millions of ingredients. Some are amazing, some are kind of repetitive, and a lot of them are just plain junk. This is exactly the problem data scientists face. Every single piece of data is an ingredient, and they've got to figure out what's worth putting in their soup.
And this whole process, this art of picking out only the most important, most impactful ingredients, that has a name. It's called feature selection. And the key thing to remember is it's not about having the most ingredients. It's about finding the right ones, the things that actually make the soup taste good, or in AI terms, the predictors that make the model accurate. So why go through all this trouble? Why not just dump everything in? Well, for a few really good reasons. For one, a recipe with fewer ingredients is just easier to understand, right? It's also way cheaper. Collecting data can be super expensive. But honestly, the biggest reason is that tossing in a bunch of junk, a bunch of those non-informative ingredients, can totally confuse the flavors and just ruin the final dish.
All right, so how do these data chefs actually do it? How do they pick their ingredients from that giant warehouse? Well, it turns out there are pretty much two main schools of thought, kind of two different philosophies on how to get the job done.
And this is where you see a classic trade-off. On one hand, you've got what are called wrapper methods. Think of this like the super perfectionist chef who's going to taste test tiny batches of soup with every possible combination of ingredients. It can give you an amazing result, but man, it takes forever. On the other hand, you have filter methods. This is more like the practical chef who just quickly pre-screens everything, sorting ingredients into good and bad piles before they even start cooking. It's way faster for sure, but you run the risk of accidentally tossing out something that could have been a game changer. Okay, but what happens if you just say, forget it, and dump everything into the pot anyway? Well, how badly that messes things up really depends on the recipe you're using, or in our case, the specific type of AI model you're building.
And this chart, wow, it just lays it all out perfectly. Look over on the left. You see neural networks? They are super sensitive. You start adding junk data and their performance just tanks. Then in the middle, random forests, they're a bit tougher, but they still take a hit. But then look at regression trees on the right. They're basically fine. They're hardly affected at all. So what on earth is going on here?
Well, it's because some models, like those tree-based ones, are kind of like smarter chefs. They have this built-in knack for just ignoring the bad ingredients. They know what's junk. But other models, like neural networks, they're a bit more, let's say, naive. They try to use everything you give them, good and bad. So they get totally overwhelmed by all the junk, and the final soup, it just tastes awful.
But here's the kicker. Even if you're being super careful, even if you think you're choosing your ingredients perfectly, there is a huge pitfall just waiting to trip you up. It's this really subtle but incredibly dangerous trap that can fool you into thinking you've made the world's best soup when you've actually made a total disaster. The statistician Frank Harrell put it perfectly. He warned that a lot of these automated methods make one critical mistake. It's like they're taste testing the soup using the exact same spoonful over and over and over again. Statistically speaking, that's a cardinal sin, and it leads to a really, really dangerous illusion.
There is a classic comic that explains this perfectly. The idea is, if you test enough different things, you will always find a connection just by pure dumb luck. You didn't actually discover that green jelly beans cause acne. No way. You just tortured the data long enough that it finally confessed to something that isn't even true.
And this mistake, this trap, it has a name. It's called selection bias. Going back to our soup analogy, it's like you've been tasting and tweaking your recipe using the same tiny spoonful 1,000 times. You've made the soup taste absolutely perfect to that one spoonful, but you have absolutely no idea what it's going to taste like to someone else, to a fresh palate. You've basically created a dangerous feedback loop by using the same data to both pick your ingredients and judge the final product.
So how do you avoid this? What's the solution? It's simple, but it's crucial. You need a friend to taste test for you. You set aside a completely separate bowl of soup right from the very beginning. You don't touch it. You do all your cooking, all your ingredient selection, all your tweaking on the main pot. Then, and only then, at the very end, you hand that untouched bowl to a friend. Their fresh, unbiased opinion is the only thing that tells you if your soup is actually any good.
Okay, so we've been through a lot. What does this all boil down to? What are the key rules every master data chef needs to live by? It's really three main things.
Rule number 1. Choose your ingredients wisely. More is not always better. Start by thinking about what's actually going to be useful. Rule 2. Know your recipe. Understand the model you're using. Is it a picky eater, like a neural network, or is it more robust and can handle some junk, like a tree-based model? And number 3, the absolute golden rule. Don't trust your own taste buds. You have to, always, validate your final model on a fresh set of data that it has never, ever seen before. That's the only way to know you haven't just fooled yourself.
Which leaves us with one last thing to think about. I mean, from the movies Netflix recommends to you, to the stuff Amazon suggests you buy, this kind of AI is all around us, every single day. And how good those systems are, it all comes down to how well their creators chose their ingredients. So next time you get a recommendation that is just creepily perfect, you can stop and wonder, what's the secret ingredient? Or maybe more importantly, what junk ingredients did they know to leave out?
Congrats, you made it to the end of this episode. That already puts you way ahead of the curve. This was just one episode of our playlist, AI Explained to Your Grandma, where we turn complicated AI into simple, clear stories anyone can understand. If you enjoyed this, don't stop here. Check out the next episode in the playlist to keep building your AI intuition. Like this video so more people can join the journey. Share it with someone who thinks AI is too complicated. And subscribe so you don't miss what's coming next. Remember, AI is shaping your world every day. The only question is, do you want to just use it or really understand it? See you in the next episode.